Hi, everyone. Thanks for coming. My name is Jared Ross, and I'm joined today by Eve Pitch, and we are Azure product managers in our networking organization. We're going to talk today about selecting the right networking solution for your workloads. We're going to focus primarily on both hybrid connectivity and internet connectivity and how to optimize that within the Azure cloud. So you're going to see this picture throughout the week. This is the Microsoft Global Network, and the Global Network is really going to be the basis of what we talk about today. The goal of it is that we want to be able to have you utilize our global network to be able to support your workloads, both from a backbone perspective, from a private connectivity perspective, and from an internet connectivity perspective. We have 54 Azure regions that are connected today utilizing our Microsoft Global Network, over 130,000 miles of fiber and subsea cable systems, 160 edge sites and growing. Yusuf this morning emphasized one edge site every week, and that's the goal. And then 200 plus ExpressRoute partners that allow for the private connectivity services. When we look at an edge or a point of presence or a peering location, what we think about is a few key pillars of this. The first one being the WAN and the core routers. This is where we bring together the Microsoft Global Network, all of our metro capacity, all of our subsea systems, et cetera. And this is also where we peer with our internet service providers across the world. We have thousands and thousands of ISPs that peer with us so that when you're entering into our network, you have an optimized connectivity solution. When we think about Office 365 and public SaaS services, which we'll dive into in a bit later, our goal here is that you're connecting to Microsoft as the closest point, and you're routing our network as far into our network as possible. We typically call that cold potato routing, and the goal of that is that rather than having you or we hand it off to a transit provider, you're going to ride our network as long as possible. The next part of it, in some of the edge sites across the world, we also have ExpressRoute, which is going to allow the private connectivity for things like VNet access and storage and SQL access. And then finally, the service that we've talked a lot about this week and we'll continue to talk about is Azure Front Door and CDN, which is going to be at the edge. That's going to be for site acceleration, global load balancing, and Eve will talk a lot about this in greater detail further in the slides. From a context setting perspective, what we look at and what we're thinking about is really the paradigm as it shifts from IaaS to PaaS to SaaS, and how we're able to build a network solution, and how you're able to build a network solution for your customers and for your enterprises so that we're providing the best connectivity solutions for each of them. We'll start with the branch. We'll go to the headquarter and the data center. We'll talk a little bit about mobile devices. And then we start to think and we dive into each one of them. We look and we see that the branch is going to need private connectivity. It's going to need to get into a virtual network, which is your own private address space. And we typically start at the site-to-site VPN capability, which is going to give you some great capabilities, encryption, some good throughput, which we'll talk about in a bit, as well as it's going to be a private connectivity over public internet. The next one's going to be point-to-site, which is going to be your mobile devices, your Windows client, your Mac client, your Linux client. And this is going to be that one-to-many scenario where I want to go into one or more virtual networks, for example, from one of these devices. We're thinking a lot about point-to-site and how we can optimize that over time so that your mobile devices have a great user experience. When you're thinking about your corporate IT structure, for example, and allowing your mobile device to now connect into corporate resources that sit within the Azure Virtual Network or Virtual WAN, for example, that's where we're going to really start to focus heavily. And then finally, from an IaaS connectivity perspective, we look at ExpressRoute as the enterprise-grade optimized connectivity service for private connectivity into peering locations across the world. On the flip side, as we look at SaaS, and what we'll continue to drive home throughout today and what Eve will focus on is our internet breakout and the direct strategy that allows us to be able to break out when we want to go from a branch or from a headquarters directly to the internet rather than going through the traditional hub and spoke model that you would see on premises where you may have a few internet points of presence. Here, what we're focusing on is allowing the branch to be able to connect as many places as possible to the internet so that you're able to get the best possible service. Now we're going to dive a little bit into our connectivity services and what capabilities we have from each of those. We talked about ExpressRoute, and ExpressRoute is going to be the private connectivity service for things like accessing your private networks via virtual network, as well as accessing public services. We have over 200 plus service providers that allow to connect and utilize our backbone directly so that you're connecting in a private and secure manner without having to go through the public internet. We see a lot of regulated industries where this is a requirement, but also as we're connecting in your MPLS networks and as you're connecting in through cloud exchanges across the world, this is going to be the best way to be able to do that at very high scale with a guaranteed SLA. And the SLA is extremely important as we talk about our enterprises, because we really want to ensure that this is up and running all the time. We have a deep dive session in ExpressRoute tomorrow, which will really go into the details of how to optimize the connectivity, how to ensure you have high availability, how you're designing for disaster recovery, as well as some of the new features around encryption, for example. In addition to this, we look at ExpressRoute as a good way of doing massive data ingestion scenarios. As you're thinking about cool or even warm storage ingestion, you want to be able to use ExpressRoute to do that. And a lot of times, the traditional telco model may lock you into a multi-year contract. ExpressRoute, like other types of services within Azure, is not fixed. You're able to deploy it, utilize it, and then delete it when you're done with it. And as we start to make that shift from the traditional hard-lined models into more of the cloud-centric connectivity models, we really want to be able to make sure that you have the service when you need it, but then also be able to get rid of it when you want to move to more of a cloud-centric connectivity model, like SD-WAN, for example. From a VPN perspective, we've got a lot of new announcements coming out from here. I'm going to go into a little bit more detail about each one of these. The first one being, we announced the VPN Gateway 3, 4, and 5 SKU. These SKUs are going to be great for the high throughput type capabilities within VPN. We're thinking a lot of customers want the encryption and they have great internet connectivity, and we really want to make that a great experience for them as well. And so with that, we're now announcing a 5 gig and a 10 gig SKU as well, which is a huge game changer in VPN, because that now gives you the flexibility to utilize VPN without necessarily needing a private connectivity solution. In addition to that, we're supporting IKV1 and IKV2 on all of the gateway SKUs, VPN Gateway 1 through 5. And that's going to allow for both legacy connectivity solutions on older router generations, as well as new protocols like IKV2 that is supported across most of the current modern router and firewall solutions. In addition to that, as we think a lot about supportability and ensuring that when you run into an issue on your gateway, you want to be able to debug it on your own. On your traditional devices on premises, you can set up a packet capture and be able to determine where the drops are occurring. Here, we're now going to give you that capability natively built into the platform. So either in a PCAP form or an ETW format, you're now going to be able to configure it with all the different parameters, 5-tuple, et cetera, and be able to configure and extract the packet capture so that you can debug it yourself without raising a support request and having to go back and forth with support. We're hoping to make that a lot easier for you. In addition to this, we've got the custom IKE traffic selectors, which are coming soon. And then on the point-to-site side, like we mentioned, we have a number of enhancements here as well. I think the big one for me, and I'm really excited about this, is the AAD and MFA authentication. That's now going to allow your client, whether or not you're on your mobile device or on your laptop or on your Mac or your Linux, to be able to have a native experience where when you sign in, you'll be able to use conditional access, et cetera, and your identity administrators can set these policies so that it ensures that you're on a certain compliant device, et cetera. In addition to this, we've got the Azure VPN Client, which I'll talk about on the next slide, but it utilizes the OpenVPN protocol, which is pretty much a standard across the industry at this point. That's going to allow you to connect in, utilizing the client and native experience. As we look at the client itself, you can see that it's natively built into the platform, and it's got a rich client that integrates natively into the AAD experience. And you can see as we sign in, we're going to get prompted in a second for the MFA authentication. Once that comes up, we'll see that we enter in our credentials. Once the credentials go through, you'll see that it's the exact same experience that you see in all of your Office clients today. You see it in all of your AAD tied apps, et cetera. That's really what we want to see this experience move towards, because that's going to allow you to have the same IT policies that have been in place for a long time. Some of the features that we're supporting on the Azure VPN Client are the OpenVPN, like I mentioned, native AAD, conditional access, multi-factor, but also the same diagnostic and debugging tools that we talked about on the site-to-site. We're going to give that to you natively within this platform as well, so that you're able to troubleshoot this for your users. And as you continue to scale out, with the new VPN gateways, we can now do up to 10,000 point-to-site connections on a single instance. And so you have great scale there if you want to do this natively within the VNet, or we'll talk more about vWAN and virtual WAN where you're able to have this managed within that experience as well. Talking about virtual WAN, we look at this as the managed hub and spoke offering within our current suite of products today. The virtual WAN brings in a number of these components that we've talked about into a holistic view. It allows us to connect branches via the internet for direct internet breakout. We can send policies down to those CPE devices, the SD-WAN providers that we've talked about in our earlier slides, a whole abundance of partners there. We also allow the user VPN, the point-to-site that we had just mentioned, as well as ExpressRoute, and those are all GA as of this week. And so you can connect in your ExpressRoute that you have your traditional MPLS or private connectivity. You can also do your VPN, site-to-site, point-to-site. And then there's some other great functionality like IPsec over ExpressRoute. And what that's going to allow us to do now is that's going to say that if I have my on-premises data center connected over ExpressRoute, and then I have 10 or 20 or 100 branches, the branches can now go up the internet, go into the vWAN hub, and then back down the ExpressRoute. That's going to now give us the capabilities to say that if we want to be able to have all of these connected in a centralized hub without you having to manage even a physical presence within that data center, especially if you're using a layer 3 provider, those layer 3 providers are going to provide you with a no hardware solution potentially, and then you just natively do this through our backbone. Even if you're entering in, say, for example, our Amsterdam edge site for internet via VPN, and you want to go all the way back to, say, Los Angeles, that will go through our backbone. And again, we talked about cold potato routing at the beginning. The cold potato routing will enter in through Amsterdam and then ride it all the way back to Los Angeles and exit back out either via ExpressRoute or into another virtual network that's connected natively via the VNet peering that runs the virtual WAN hub. From a preview perspective, there's two exciting announcements here as well. The first one being the any-to-any connectivity. This is where we start to be able to build a really sophisticated hub and spoke model where I can have VNets peered on the hub within a given region, and my branches are connected in that region and that hub. They'll enter into that hub, and then I now have another hub that sits, and we'll use the example again. Maybe we're in North Europe and West US. Those West US and North Europe's hubs natively talk via the SDN fabric, and as you add more branches and as you add more VNets, they all natively have any-to-any connectivity so that as you continue to add more VNets, we continue to be able to build the routing model for you. The other one is the Azure Firewall integration via the Firewall Manager, which we announced earlier today. The Firewall Manager is going to give you the capabilities to be able to manage many firewalls via a hierarchical model, but it also is going to allow the integration into the virtual WAN hub so that as you're thinking about internet breakout within the hub, and internet breakout is going to be a really important conversation as we talk about optimizing connectivity to Office 365, for example. That's going to be natively integrated into the virtual WAN hub as a preview as well. And then the next section we want to talk about is the private enterprise global backbone. As we think about the private enterprise global backbone, we really want you utilizing our network. We've got 160 edge sites, as we mentioned, 54 regions, a lot of ExpressRoute locations, and each one of those is going to play a pivotal role as we're starting to design out the next generation of our networks. Today, we look at a traditional enterprise private network. In this case, I chose a restaurant example. As I have restaurants distributed across the world, we traditionally would build some sort of hub and spoke type model. And the hub and spoke, in this case, is very physical. It requires aggregation devices, it requires pretty beefy internet connections, and even in this case, we just have 1.5 megabit DSL connections coming out of these restaurants. But in this case, I've got a Minneapolis-based US data center, VPN aggregator. It's got some compute on-prem, I've got some VPN devices on-prem, and each one of these connects in basically through these two major hubs. I then have a 10 meg MPLS line that's going between Minneapolis and London. It's pretty expensive, and whether or not I'm doing MPLS or I'm doing a private line, I'm going to have to maintain that, and I'm going to be locked into a fixed contract, etc. I want to be able to move past that, though, and I want to be able to scale at cloud scale. And as I do acquisitions, and as I think about what the next generation of my network is going to look like, I want to be able to use a provider that is truly global. I want to be able to have the capabilities to add new sites and grow scale and add throughput without locking myself into that. And that's where we start to look at how do we utilize Microsoft's global backbone and the private network that we already offer so that you can support your customers and your enterprises when we're thinking about growing and when we're thinking about building your own network from the ground up again. We have an offering that we announced at Ignite last year, which is called ExpressRoute Global Reach. When you have ExpressRoute deployed in various locations across the world, they're already connected into the Microsoft global network. Your service provider, or whether or not you connect via ExpressRoute Direct at 10 or 100 gigs, we're going to allow you to now take those circuits and connect them together natively within the ExpressRoute backbone. Sorry, in the Microsoft global backbone, rather. It builds your own private network so that you completely manage it, you control it via BGP protocol, and it allows you to scale as your company scales. The traffic stays on our global network the entire time, and we guarantee that. We run our own network end to end. We light our fiber across the world, and that allows us to be able to scale as our customers scale. You'll hear many times that we plan always for 10, 20 plus X growth in our network, because not only does our network run things like Office 365 and Bing and some of the most important ones like Xbox, but it also runs all of your services, whether or not they're your SaaS services or your internal line of business IT applications. You want to be able to have a secure and protected network that's going to allow you to ride on our network end to end. This is also redundant by default. Whenever we're thinking about the edge site, and we talked about that picture right at the beginning, which has the core routers and the ExpressRoute routers and the AFD and CDN, that edge site is built so that we have redundancy in place. There's multiple connections going from that edge site into the global network, and not just to one path. It's going to multiple paths in multiple different directions with diversity, and we ensure that along the way because we want to make sure that when you're building your network on our network, that it scales and it's reliable, and we want to also give you a pretty good latency profile as well. That's important as we think about ensuring that you have a great experience on our network. In addition to that, this is supported in a bunch of locations, pretty much in every market across the public cloud, every major market rather, as well as in the Azure US Government Cloud. And we think that there are a lot of great use cases here as customers are thinking about designing their private network on Microsoft's backbone. This is what we think a modern enterprise network is going to look like. Maybe not today, maybe not tomorrow, but in the near future. And as you're starting to think about designing your global network, start to think about how you can utilize Microsoft's global network. You don't always need to use every Azure service, but some of these services provide you with the baseline so that if you want to be able to connect all these restaurants together, we now think about it in a slightly different way. We think about our branch-to-branch connectivity and our branch-to-VNet connectivity via the Virtual WAN hub. We now have the hub-to-hub and any-to-any connectivity. And so now when I'm going from Boston to Fargo, North Dakota, for example, I want to ride my backbone to do that because maybe my restaurant or my corporate office in Fargo isn't that large. And I don't really want to invest that much in it, especially to get a backbone connection back to Boston. Utilize the internet to do that. Get into the Virtual WAN hub within North Central, for example, and then ride our backbone to get back to Boston. That will natively happen via the vWAN any-to-any connectivity. But I also want to make sure that I have a high-fidelity connection between my US and EMEA data center. And as those continue to grow and as I start to do replication, asynchronous for backups and SQL, I want to make sure that I have that connection. And so what I do there is I now have my ExpressRoute connection in London. I have my ExpressRoute connection in Chicago. That's going to give me great virtual network access. That's going to give me great Azure storage and Azure SQL access for the data ingestion. But I can also then enable global reach just through the native integration that we have. And just a few clicks, and I'm now able to establish that end-to-end connectivity between London and Chicago through our backbone. And then that also gives me access to my on-premises data centers. And so if I'm in my EMEA data center and I'm in my US data center, I can go between the two of those, and I actually never have to access an Azure service. So I can utilize and create my own private backbone without actually even needing to use the Azure services. Now, we'd love to see you use the Azure services because there's a lot of great offerings there, but really when it comes down to it, this is how we think the next generation of the network is going to look. We also announced the ExpressRoute satellite connectivity that GA'd today. And what this is going to do is this is going to give us the capabilities when you're in remote parts of the world, cruise ships and defense and peacekeeping missions, et cetera. This is going to give the same rich capabilities that ExpressRoute has today, but across the world and in any part of the world. It's not going to be as performant. It's going to have some latency, of course, because when you're in the middle of the desert, it may look a little different, and the connectivity might not be exactly there. But we have strategically placed ground stations that we've worked with these 3 major partners with today so that they're connected in strategically so that when they enter into our network from a satellite to a ground station, they're going to be optimized and then ride on the Microsoft Global Backbone privately once again. We know that this is all a big change, though, and there's probably a lot of network engineers in the room, and we're thinking a lot about how we're going to make this experience much better. And we want to make sure that you have a great experience when you're building out your Azure networking environment. The Azure networking is going to look a lot different at first than what you've traditionally seen on your on-premises hardware. And we want to make that transition as easy as possible. SD-WAN is really a game changer in this industry because it provides a management capability and it provides native routing capability and optimized routing capabilities. But we know that the enterprise is going to need some experts in this area to either kickstart or to be able to continually manage for you. And we've introduced through the Azure Lighthouse program, the MSP offers, specifically for network. These people are trained and these organizations are trained in how to build up Azure networking. And these are going to be fully managed environments or partially managed environments. The way we like to look at this is these MSP offerings really allow for you to be able to tailor what the experience is going to be, whether or not it's a fully managed environment or whether or not it's an environment that's a little bit focused on a specific area, maybe the network security portion or maybe the SD-WAN portion. And this goes hand in hand with our virtual WAN offering. This goes hand in hand with our ExpressRoute offering. And each one of these is going to be really specialized to build and manage the modern cloud enterprise network. In addition to that, with the Azure Lighthouse integration, these service providers can gain access to your subscription via your authorization model, via the traditional RBAC that's built into ARM, so that when you're thinking about managing these types of environments, they can manage both the CPE devices that sit on premises, the customer premises devices, like your routers and your switches and your firewalls, but now they also have the capability to manage the Azure Virtual Network and the NSGs and the Azure Firewall. All of those can be managed centrally within the MSP environment. And you're thinking about your next generation of your network and your next generation of IT. This is what's going to give us the flexibility to do that and also scale at the same time. These are the same experts that have been doing networking for years and years, but have made the transformation to the cloud networking paradigm. With that, I'm going to introduce Yves, and he's going to talk more about the internet connectivity services that we have, as well as Azure Peering Service. Thanks, everyone.
Thanks, Jared. OK, so just checking, how many of you are using VPN or ExpressRoute solutions to connect to the cloud? Wow. How many are using public internet? Bless. How many are using Office 365? More, OK. All right, so the purpose of that talk is to address customers who are looking to either have an internet-first strategy or an SD-WAN solutions, or for customers who have a dependency or who rely heavily on SaaS services, such as Office. And this is what I will talk about. So Jared talked about the private connectivity portion. Now we'll talk about public internet, how we can leverage the public internet to use these services. So one of our goals is to make sure that if you have such SaaS services in place, we want to make sure that you have the best internet experience in terms of reliability and in terms of performance. And that's what we're trying to address. So let me give you a scenario. What you see here is our global network, a very simplified view of our network. So it's a cloud. And on that cloud, we host highly distributed SaaS applications. I will take Office as a scenario because it's the most well-known SaaS services we host here. So when I say SaaS service, it means that this code can run anywhere. It can run on US West, it can run on US East, it can run in Europe. We don't really know where that code is running. It's distributed. Now, at the border of our cloud, we have these edge POPs. So we have 160 of these edge POPs. So it means that anywhere that internet traffic can enter any of these POPs. So which one do you pick? So do you need to ask your ISP to connect to the edge POP that is as close as possible to your mailbox or SaaS service? The answer is not so sure because we don't really know. You may infer where that mailbox is, but it's not the right approach. What we want and what we believe is the right approach is to make sure that you are connected to the closest or the nearest POP from your location, from where you are. So that's key. So connect to the shortest path, nearest POP. When that traffic is entering that edge site, what we do, first we know where to send that traffic because we are aware of their SAS specifics, or we know where the mailbox is. So we send that traffic using SDN-based policies, optimized for performance. We have the right capacity in place to make sure that traffic is no jitter, high performance delivery. And then we'll also use services such as front door to accelerate the traffic. So front door in that case can terminate SSL connection and proxy back to the origin of the service. So it's highly optimized. So this is why the best practice is to make sure that you connect to the closest edge POP. The second best practice is to make sure that between you, customer, and us, Microsoft, there's only one hop. We don't really like intermediates. So there's a trust chain that you need to have. So when you have to deliver or go over the internet, we want to make sure that the provider of that internet connectivity is the only guy in the middle. So that's what we refer as one hop away. So in that map, the top left is the one we like. We like the shortest path. Bottom left, not so much, because we lose accountability here. Like if there's an issue happening between your branch office on the cloud, who is accountable for what? So it's a bit tricky here. On the right side, this is a common pattern, by the way. What you see on the right side is that traffic is taking a longer path over the internet because at some point, there's a belief that we can carry the traffic to where your mailbox or your SaaS services is running. And that's what we're trying to address with the new peering service. So this is why we are introducing a new Microsoft peering service, which is composed of two things. First is a partnership with our telco providers. So we have reached out to all our partners, and we said, OK, so for the customers willing to use the internet to access to the cloud, here's a list of things you need to meet from a reliability perspective. So when you connect to us, make sure you have what we call geo-redundancy. Make sure that if a session is going down, you can fall back through other path. That path has to be short as well. Make sure we have the best practices in terms of routing and whatnot. So we came with a list of requirements. We reached out to all our partners and say, OK, let's work together so that you get the best performance. So that's one aspect of the program. Second part is we want to expose you what's going on. So from your branch or your location to the cloud, it's very important that you know the latency. You know any type of events that could cause degradation of the performance. So if an edge has a session going down, your traffic may go through other locations. So you may be impacted by the performance. And that's what we're trying to address here with the telemetry package, which is optional because you may use your own telemetry solutions. But in that case, here we provide performance insights about latency. And we do also what we call route monitoring. I will show you a demo later. So you know the internet is based on BGP protocol. So we exchange packets between networks. And we advertise routes, and sometimes these BGP configurations are not the most, lots of issues can happen, misconfiguration, intended or not, but we're trying to make sure that we have the right monitoring in place so that we can tell you that, hey, something is happening here, your provider is notified, you are notified, and we are working on it. Here's the logical view. So you have three personas here. You have the provider, who is giving you an enterprise-grade internet to Microsoft. We have Microsoft, the cloud. So when I say Microsoft, it's Azure or Office, or any kind of Microsoft properties running on our cloud. And you have you, the customer. Now, we are all sitting on the same platform, which is the peering service platform. So this is used to exchange information. So when something goes wrong, because we do monitor the internet, then we tell the provider, hey, something is wrong, and by the way, this customer is impacted. In that case, we can take remediations and address that issue immediately. So we are all sitting on the same platform. At the same time, you also get the same type of information. So you get the events about performance. And the purpose here is really to open the kimono, and make sure they have the best performance. So we do monitor the internet. So this is about 20 million routes every 5 minutes almost, I think. Every day you will have leaks, hijacks, any type of things happening. And it could be a misconfiguration. And as soon as you have such an event, your traffic is highly impacted. So just go on a search engine, type BGP hijacks, you will find tons of events about that. Then you have the performance. So we want to make sure that between your location on our cloud, you have the best performance. So we start to expose you insights. Insights between the performance between the user and the end service. So we have started the preview service, the preview of Azure Peering Service with these launch partners. So if you are a customer of one of these, you can reach out to them and start the trial. More to come. So I think we have coverage over Europe, Africa, Asia, US. We'll have more coming in the US. All right, so let's show you how it looks like. So I'll take a scenario. So in my scenario here, I have a customer. That customer has a branch in Paris and a branch in London. And he has purchased connectivity services from Intercloud. And Intercloud is sending traffic to us. Now, the Paris branch has been allocated an IP prefix, a /24, that is attached to that location. And the London branch has also a prefix attached to it. A few acronyms here. ASN, if you're not familiar, it's the unique identifier for that network. So that's called ASN. BGP is what we use the protocol used to route packets across networks. And the hijack, I will show you a hijack demo. The hijack is a takeover of an IP or group of IP addresses from somebody. So if somebody is taking over your IP addresses, it means that this traffic will be attracted by somebody else. So highly impacting events that can cause lots of disruption. So what I will do, I'll set up a peering connections. I will try to monitor the connection between London and Microsoft. So London has a specific prefix, and I will describe that configuration inside the Azure portal. So let me switch to So here I am in Azure portal, and I will create a new resource called peering service. Oops, let me go back to the Azure portal. So I'll add a new resource. I call it peering service. Create one. This is my resource group configuration, and I name my site. So it's your location. This is your physical location where you are. So I call it my site. It's just a logical name. Then you define where your branch is. So this is a physical location. So I said I'm close to London, so I'll pick a state close to London. I pick Kent in that case. And I use Intercloud here in my demo. Now, that branch has a prefix attached to it. Right? So I can add a prefix here. Hopefully I still have it. So this is my prefix attached to it. So I click Next. And that's it. So now you can see that the validation passed. So let me give you some scenarios about what we're doing behind the scene. First, I'll go back. And I entered Kent. I peer with Intercloud in London, so not so far away. So we believe that that user in Kent will have the best performance when connecting to Microsoft. If I pick a different location, let's say pick Berlin. I get a warning here. So if my branch is in Berlin and use Intercloud, assuming they're in Germany, if I don't peer with Intercloud in Germany, here what we raise is like, hey, the closest entry point with Intercloud is far away from your location. So you may not have the best performance to access to the cloud. You can override that rule, but we are telling you that you are not as close as possible to our network. So I'll go back, pick the good scenario, Kent. Click next, and create. So behind the scene, we are checking a couple of things. First, we are checking that the prefix you have entered is indeed one hop away from us. So between you and us, it's only Intercloud. We are checking that. We are checking that if that route is indeed advertised by Intercloud. That's important as well. We want to make sure that we trust the partner in the middle. We are checking that if that session is going down, as soon as they peer with Intercloud and use Intercloud, if that edge is going down, I want to make sure that I can always go back to you through other routes. So we call it a covering route or backup route. So we want to make sure that the internet traffic is still going back to your location through other types of advertisements. So that's what we're doing as well. So this is done behind the scenes. So I'll go back. So my resource is completed. So I go to my resource here. So this is what you get. The prefix I just entered is here. And you can see the validation state is passed. So I have a covering route. I'm one hop away on whatnot. So I've been doing that demo for some time. You can see already some latencies already displayed. So in that case, what we display is like for the users behind that prefix, the average latency is, yeah, you can see 12, 15 milliseconds. That's the user latency. It means a user to the cloud. And so now let me show you other types of events. So I go to my prefix here. And I can show you some events. So as soon as I create that connection, I have two types of events. The first one is called primary path. It tells me that this AS number, which is my identifier for Intercloud, is the only hop between the customer and me. So I am indeed one hop away. Now, if that connection is going down, the backup route is also Intercloud. So Intercloud has done some work, some geo-redundancy work, to make sure that traffic is going back to the right place. So that prefix is a larger block that is used to route the packet to the right location. So this is important. If you don't have that, you're maybe exposed from a reliability perspective. Now let me show you something else. I'm switching to that view. So I'm not sure if you're familiar with Thousand Eyes. Do you know Thousand Eyes? Few. So this is an internet telemetry tool that can be used to monitor performance. In that case, we measure the hop between different sites. So on the right side, you have that branch sitting here. So this was my branch in London, right? The traffic will enter the edge. And then let's say I have multiple destinations. I have Chicago, I have Sydney, Tokyo, and Amsterdam. So I'll zoom a bit. So traffic enters our edge. We go over our backbone up to the destination service. Now the return path will be symmetric. In that case, the return path from Chicago, in that case, will go back on our backbone up to the edge that is as close as possible to your location. So we force traffic to be what Jared referred as cold potato. We bring the traffic as close as possible to your location, and this is guaranteed. So this is what you get when you register for the peering service. All right, so now let's go back to the events. So I'm supposed to have a bad actor in that room here. Let's see if it's coming. The event is supposed to come. OK. So as I said, I have a bad actor in that room. Something bad happened. What you can see here in that red flag is what we call a hijack. So somebody is trying to take over a prefix here, that prefix. If somebody is succeeding to take over that prefix, you have 0 connections. You are dead. So let's look at who is that guy. So the AS number, again, my unique identifier, is 62540. So I use that tool to understand who is that AS number. And you can see that the company is called Drake Holdings. Good news, it belongs to Microsoft. So we have the bad actor here. He did a hijack with one of our owned fake companies, and he tried to hijack. Now, so what do we do with that? Because this is happening every day, and many customers are impacted by that. So with the peering service, in fact, we guarantee that the traffic will still go. The traffic from Microsoft will still go to your branch in London in that case. So we detect the event, we override the policies to ensure that traffic will not be steered against Drake Holdings. And that's key. Now, if you have the same provider giving you access to other folks, non-Microsoft folks, that's not happening. So we guarantee the traffic coming from Microsoft to you, but for other scenarios, you should reach out to your provider because you may be impacted by your other properties running on other clouds. So and that's key here. We want to make sure that between you and us, there's a trust relationship. We enforce the traffic to go to the right place, and we detect any type of anomalies. We override the policies and bring the traffic back to the right location. So that's what you get with the peering service. So this is the end of the demo. So let me switch back to, I think it was 4. Yeah, so this is what I just did. I configured the London connection. You can create as many connections as you want. And you get more and more insights. We keep exposing that information. The hijack I just showed you, you get the event, the provider gets the event, and our support team will get that event as well. We want to make sure that we also address the root cause of that hijack. That's key here, right? All right, so, oops, here. So just to summarize, when you select the peering service, you have 2 steps. The first one, we are not in the loop. So you have to reach out to your provider and say, give me internet connectivity, enterprise-grade internet connectivity. But I want to make sure you pick the option that will offer the peering service. I do not call it certification, but peering service compliance. And so all these providers will have a solution for you. You take that, and as soon as you do that, what I just showed you in the demo can happen real time. So you can just do one. You pick a carrier, and that's it. In that case, if you pick the carrier who will have that list of compliance requirements, then what you get is a well-connected custom carrier to Microsoft. If on top of that you add the telemetry package, you get the telemetry I showed you, and you get the internet routes monitoring, so BGP type of issues I just showed you. You get that, and you will get forced traffic prioritization to the edge as close as possible to you. So that's what you get with the telemetry package. All right, so a couple of things. So I went fast on the front door capabilities on internet first strategy and whatnot. So there's a couple of sessions you could follow up. There's one about front door capabilities and also about internet first strategy, so which is, I believe, the securing your cloud perimeter with Azure Network Security. In that case, I did not talk about your security appliances, whether it's firewall, DDoS, or whatnot. These are elements that can impact your performance to the cloud. And I think I recommend you to go to that session to understand how to deal with security appliances when connecting to SaaS services. All right, so any questions? Yeah.
So first, quick clarification. You mentioned that the ISP will provide a range of IPs to the end customer. So the end customer doesn't have to have an ASN or register for their own IP address, correct?
Yes, you have two scenarios. Some carriers will provide the IP range to the customer. Some large customers, they have their own ASN, and they want to advertise their own AS number, so which is OK. We support both scenarios. So you have different categories of partners, ISPs, Internet Exchange partners as well, or what was called SDCI, Software-Defined Cloud Interconnect, which will provide L2 connectivity to your location. But we do support both.
And for the backup scenario you mentioned, is that being taken care of by the end customer or by the ISP?
So important question. So is it so is the backup route covered by the carrier or the customer? First, the carrier itself has to do it. So we will block any kind of registration if there's no backup route. Having said that, if you only have one fiber out of your building to your carrier, you are still exposed to your single fiber. So the carrier may come back to you and say, if you need 5.9 availability, you may want to have diverse path, which is OK if you have multiple locations. You may have one fiber and the traffic will fall back. But what we care a lot, more about all is to make sure that the traffic can always go back. Even if you get a degradation of performance, that's OK. But losing the packets is what we hate the most. Yeah.
Thank you.
Yes.
Multiple, sorry?
Multi-home?
Yeah, absolutely, yes. Yeah.
Yes.
My understanding is that the Azure VPN Client, which we've seen on the slides, is review. Actually, 3 questions related to that.
Sure.
I've been using the...
Do you mind using the mic? Sorry. Yep. Thank you. It's good. Go ahead.
Right, so actually 3 questions.
Sure.
One, would this include a proper MSI installer or something for the mass deployment of the Azure VPN Client?
Yeah, good question. Yeah, we will have the SCCM integration or the ability to be able to deploy via standard deployment tools.
Okay, is it customizable? Like you can inject additional routes which you would like to have enabled by through, let's say, through the VPN? Because now it's like a split tunnel.
Yep.
It only includes the, let's say, the subnets which you have on Azure and via
We do have custom route support. If you want to stop by our booth, though, later on this week, we're in the main convention hall. I can make sure I get all the questions answered, then come back to you.
Right, so just
Sure.
Well, one additional question. The client today requires local admin rights to be able to run.
Yep.
Has this been improved?
I'll answer that one as well at the booth. I don't know the answer to that. But yep.
All right, thank you.
Thanks. Any other questions? Say that again? For internet or for private?
For peering, we just provide the connectivity. Then any type of services are supported on our end, as soon as the traffic is going to Microsoft. So the optimization is traffic from your location to Microsoft. The provider will not optimize any, can optimize, but in that case, we don't cover any services outside of Microsoft.
Once it enters the Microsoft network, though, we're going to do all the software-defined optimizations and ensure that, like Yves mentioned, the jitter is reduced, et cetera. But in terms of quality of service or class of service, it won't be carried.
Oh, class of services.
Yep.
Yeah.
Yep.
No, there's no QoS support right now.
Yep.
Yeah, sorry, my bad.
Any other questions? Thanks, everyone.
Thank you.